Welcome everybody. This is probably the last, we have one more set of presentations after this. So, as I said in my previous presentation, I'm sure all your brains are fried and melting out your ears at this moment, so hopefully we can make this talk a little more fun and informal and keep everybody engaged. So first of all, my name is David Blevins. I've been involved with the JavaEE specifications since EJB 3.0. That's what, 2004 or 3 or something like that. And then ever since. And I really enjoy the participation. I was involved then in EE6, now EE7. And of course EJB 3.1 and 3.2, and sort of informally on CDI. The really great thing about CDI is you don't actually need to be on any group. You can just show up and participate. And in fact, most of the people on that specification are not on the spec. It's kind of where we should be going as a JavaEE spec group. Yeah, so here, let me ask some questions. Who uses JavaEE? Great. Just wanted to make sure. Yeah, so this is really relevant. Who's been using it for more than 5 years? Wow, so that's really cool. So that means JavaEE 6 must have gotten a lot of you into the market, which is what we're seeing a lot of people kind of coming into it because of some of the things that are in EE6. All right, well, so if you've ever wondered how the thing that you're using gets created, not the implementation of it, but the specifications and ideas, on how that stuff gets there, well, that's what this presentation is about. So if you're here to learn all the new addition, stuff in JavaEE 7, I think that's going to be covered quite well over the next 2 years. I will have a couple bits on there, but this is really to give you insight into the process itself. And so here's an opening part. I call this how JavaEE specs were made. Okay, so we have a JavaEE spec and we love it and adore it. And here we got the nice little clever JEE, J2EE in Roman numerals 1.4. Sometimes specifications get called dead because things like Spring come along and say that JavaEE is dead and so they die. Ugh. And then sometimes we have other ones which they last for a while, but we think maybe it's time for a new one. So we go ahead and we have all the experts go into the Java community process while all of us people in public stand outside and wait. And what they do in there, we'll never know. It's entirely secret. All we can do is just stand around waiting for symbols of, is something happening? So we're waiting for smoke signals because we don't have any insight on what's going on in there. And when a black smoke comes out, that means someone proposed an idea that got shot down. And what that idea was, or what it was about, or who was it for, we'll never know. And then eventually, a couple years later, when we see white smoke, we know, oh my gosh, now there's a new JavaEE version for us all to enjoy. This is wonderful. This is awesome. And then we get our new spec version, and we use that for a couple of years until we have to repeat the process. This is how specifications were made until this happened. So JSR 348 was created to address this effectively closed process, and I was really tempted to put Java community process with like this community crossed out, because as you can see, when just a select few walk into a secret room and make a decision for us, that's not really a community process. That's really, So what JSR 348, I like to say in fun terms, it puts the C back in the community. And so it has some basic rules, and now all of the JSRs that go through the Java community process have to adhere to these rules. And these rules are to ensure transparency and that everyone has the ability to participate in specifications, not just in JavaEE, but in the JCP in general. So the secret process can now no longer happen. And so, some of the things are you must be transparent. And how they guarantee transparency is still in progress, but what we have now is all JSRs must have an open mailing list, and you must be allowed to participate in those mailing lists. So all JSRs have a users list and an experts list. I don't really like the term experts. I think that discourages participation rather than encourages it, but we'll save that fight for another day. We now at least have open mailing lists where you can see all the talks and everything that's going on in the expert groups. They have to have a public issue tracker, so when ideas are being talked about, they create a JIRA for it, and then everyone can comment on that and see what's going on there and where the discussions are in that. And there are even provisions that if there's a lame duck spec lead, I mean a spec lead that isn't doing much, there are even provisions from kind of yanking that person from their spec lead position and putting somebody else in there. So there are a lot of really good stuff going on. That was just the beginning. There's actually going to be a subsequent version of JSR 348, a new JSR that's going to do even more to try and address openness. So this is the new JCP. This happened early to mid in the JavaEE 7 timeframe. All the specifications started out a little closed, as they were traditionally were, and opened up throughout this process of JavaEE 7. So this talk is basically what's with the black smoke. What were these ideas that got thrown in the fire and burned up? And you know, we're going to talk about a couple of them that succeeded and why they succeeded. But really the point of this talk is to try and give you the experience of having participated in the JCP in this process for the last 2 years. Give you some insight on what was there, what would happen, how to participate better. And you know, also to if you like any of the ideas, a lot of ideas are not killed. They're simply, we'll do that later. And so if you think that they're really good ideas, I encourage you to get involved. And ultimately, I want everybody in this room participating in the JCP. I mean, basically, who do you want creating the technology? The people waiting outside, or the people in, or the half dozen people in the room? Basically, you should be involved in creating the technology that you use. That's my firm belief, at least. And so, ultimately, that's the goal here. Teach you how to get involved with the process. So, let's first start out by talking about the first idea that was essentially canned and killed. Who have you heard that cloud was supposed to be in EE7 but was discarded? Who have you heard that news? Okay, so 5, 6 people. So that's more than you would have heard, because previously it would have been 0. So yes, there were some ideas for cloud that were scheduled to be in EE7. This was a really big push by Oracle, and it was very ambiguous and very soft. And you know, to be honest, it was more marketing driven than substantive. And so conversations attempted to happen around this, but didn't go too far. Some of the ideas they had were very loose. There was like, okay, let's design JavaEE for multi-tenancy. Okay, but what is a tenant? And all right, well, we're not going to answer that. We're just going to do it. And so that kind of became a nebulous thing. And then, all right, let's make a configuration API for the cloud. It's like, well, we kind of already have an API to allow us to configure our applications, so that's kind of solved already. So, but when you're talking about let's make a new configuration API, there's 1,001 ideas that get thrown in there, and so now everything's open to question. One of the examples was, here's how we might configure stuff now. This is a kind of a copy of an existing annotation. The existing annotation is data source definition. So it's very simple. You know, the name of the JMS connection factory, the description, what user would you want, what password you want. So one of the ideas was, this is not complicated enough for cloud. We need to really make this much more complicated. So let's use maybe annotations for all of the values of the annotation. So I put them in red so you can see, you know, everything in red would be an annotation class that you would have to use to configure this annotation. So that would look something like this. So all the red are exact, you know, annotation instances, whereas in the past you might have been able to say name equals in a plain string. Now you got to say name equals name annotation, then the name annotation, and then guess this, magic configurability thing. That was the whole driving this thing. JavaEE for the cloud must have configurability. And so that configurability annotation would basically say, you know, if I've supplied a value, are they allowed to change it when they push it into the cloud, yes or no? And so that's what was driving this whole thing. You know, when I hard code my stuff, you know, what's allowed to be overridden and what's allowed not to be overridden and what must be overridden. Kind of a good idea at heart, but this was a bad API. So eventually, Cloud was killed. And when that happened, an email went out to the expert group mailing list, which is of course visible by the world at this point. And then this popped up on InfoQ like the next day. And it was quoting that email from the expert group. And in fact, I didn't put it all here, but myself and 3 other people from the JavaEE expert group were quoted in saying, you know, this was a really smart move. JavaEE's already about, portable little application units, so it's, mostly ready for the cloud already. This is very good. And I thought, when that happened, I don't remember being asked by any reporters, I thought, wow, that's a really significant change in events. Now, when people talk on the mailing list, they're publicly held accountable for what they have to say, and that's fantastic. So we didn't see too much more of that because not a lot of the potential additions get as much hype as JavaEE's about the cloud as JavaEE 7 did. But I thought that was really kind of a turning point in the whole way we do work. So I thought at that moment it would be good to do a presentation really about the ideas that don't make it. And so this is what we have. So after EE's cloud snafu, and that got shelved and put off till EE8. Then it was, what else are we going to work on? So one of the ideas that came up was, how you have to put your database passwords in your configuration files, and that's a big pain. So let's find a way to get passwords out of configuration files. So this led to a proposal from the EE spec lead Bill Shannon, which would basically allow you to kind of put this alias equals some key, and then that whole thing would be replaced with a password. And then you would put your passwords in some sort of database store or something like that, or some other external store. So ultimately, sort of a good idea. Nobody likes to have passwords in their text files. But where do we put them? Well, that kind of never got there. That's the real hard part and not the syntax. The hard part is where you put them and how secure is that. And so that really never developed. And here's sort of some of the proposed syntax, how that would look in an annotation. You can kind of see that yellow line. And here's how it would look in XML. But then again, like I say, where it would happen never really developed. So this got canned. But of course, as you'll learn throughout this talk, while this is being talked about, someone has a better idea. Let's do this instead. And so this happens a lot in committee processes. So while that conversation was going on, Jason T. Green of Red Hat proposed what I think is a better idea, which is property substitution. Well, why do it just for passwords? We can take and solve that password use case by allowing anything that's in a deployment descriptor to be substituted. So, very much ant style dollar parentheses. So something like this. So all of the content of the deployment descriptor can be externalized. It starts to look pretty good. And when you do it in annotation, it doesn't always work because not everything is a string, so we do run into some limitations there. But ultimately, it's a decent idea. Now, let's ask an informal poll. Who would have taken Bill's proposal? Okay, 1. Who would have taken this proposal? All right, that's 2 dozen maybe. All right, well, after that, I thought to myself, we do something a little bit, I work on an app server called TomEE, we do something a little bit different there. We just say, well, if you do it like this, basically you're spending your all day typing in copying the name of the tag in. And then ultimately you don't know what your default configuration is, and you can't see anything. So effectively, you've got an XML file with your repeated tag in every single place, and you've basically accomplished very little. So other than to say, yes, I can substitute things. So the idea that I presented was, let's just allow people to override anything that's in XML or nearly anything, and just instead of you know, having if the data source definition's name is foo.ds, go foo.ds.classname and just say what it is. Then you can leave the default versions in the code and still have the ability to override it. So now, for those of you who raised your hand before about accepting Jason's proposal, who of you would still be 100% confident that you want Jason's proposal instead of this proposal? Okay, now only one hand. So, welcome to the specification process. This is why a lot of ideas don't make it. Not because the one idea that's presented isn't great or really wonderful. It's just that now when another slightly different idea that could potentially accomplish the same thing gets presented, then that makes it really ambiguous. So, gee, which way do we go? Ultimately, what happened here, none of these ideas got in. And so, you know, when the spec lead wants it one way, when a big group wants it this way, when other people want it this way, it's to get cohesive thought in that is you know, is difficult. Really, the tiebreaker here needs to be a lot of user feedback, which is why I say it's important that you get involved. So if you have a specific perspective on anything like this, getting involved is what breaks these ties, what moves things forward. So, you know, the slogan of Java is, let's move Java forward. Well, that really needs to include the world. Everybody uses Java. Okay, so let's talk about something that did get in. It shouldn't have got in. It should have, but so constructor injection. All right, so in EJB 3.1, I actually proposed constructor injection for EJBs, and then it got you know, -1 by somebody in the expert group. That was a closed day, so I can't talk about it then. But then we reproposed it, or I did. And for what happened was it was really interesting. So I proposed it to the EJB expert group. Somebody in the group said, no, that's not a good idea. We should focus our attention on more important things. And then what happened was it got added by Gavin King in CDI as a requirement in the CDI spec. So thank you, Gavin. And so effectively, constructor injection for EJB got added into the CDI TCK. So then as I'm implementing all the CDI integration, I thought, hey, there's a test that tests EJBs can have constructor injection. This is awesome. I wanted to get that feature in. This is fantastic. So it got in indirectly, kind of around the EJB expert group, and so that was really cool. So then while we're implementing that, I thought, well, as long as I'm going to have to implement it for EJBs, let's do it across the board for servlets and everything. And so that's what we did, and then I added a JIRA. I thought, well, if CDI got it in before, let's put the request into CDI 1.1. And then, so that was a feature request I had in for CDI 1.1 to have constructor injection for everything. And interestingly enough, that went back into the JavaEE expert group, and then it slowed down, and 2 years went by, and there was no action on it. It eventually did get picked up by Linda, the co-spec lead of JavaEE, and added to the TCK, added to the spec. So now we will have constructor injection across all JavaEE components in JavaEE 7, which is wonderful. So now you can have a servlet with, you know, private final variables and use constructors to get those passed in and, you know, do basic good Java programming. If you don't use final wherever possible, I recommend it. It's good programming. It's sort of a tangent. It's sort of unfortunate that default variable type is a mutable variable type. Really, that should be the exception, not the rule. Use final wherever possible. Anyway, this, yeah, so here's what, you know, constructor injection, wonderful. This was really difficult to get this very simple thing in. And I think to myself, why was this so hard to get in? And ultimately, I think it was so hard to get in because there was no ability to write tests for it, just show how basic this is, and just drive the conversation forward further than I think we should do this. Ultimately, the TCK itself, the tests that are JavaEE, you see a specification, but we see tests. And so, you know, if there was some ability for people to contribute to the tests, that's one way of driving concreteness into conversations and moving things forward. I think that probably would have broken the back of this feature request and gotten it in much sooner rather than under the gun at the last moment. So another thing, this partially went in and partially didn't go in. So you'll definitely be hearing more about this in JavaEE 8. And it's something that has been titled Manage Bean Alignment, but really you're going to need to read through the lines. What this is ultimately about lining up CDI and EJB. So who's familiar with CDI? Okay, very few people. So CDI is a new component model in JavaEE. It's a dependency injection framework. It's marketed as a dependency injection framework, but ultimately it's sort of the new end-all be-all component model for JavaEE. It allows you to basically declare components and have interceptors around them, decorators around them. Decorators are basically, standard delegation, and has a cool event model. And you're going to find when you Google CDI, you're going to find a lot about the dependency injection, but very little about the fact that it's got an awesome event model. So research the event model. Make a note that CDI events and observers, is what they're called, are the bomb. They're really great. They're awesome. Okay, so why do people want to align these? I think the best way is to just show you how these things work. So I'm going to try a Herculean attempt here, which is to summarize two different specifications in about 2 minutes and give you how these things work, and let's see how well I do. All right, so when you reference an EJB or a CDI bean, what you get is not that actual instance. What you get is a fake. It's a proxy. And when you make a method invocation on that proxy, that method invocation goes to the container, where the container will find the instance that you're referring to. So if you have a stateful instance bean, it knows where to find it. If you have a stateless instant bean, it grabs a bean from a pool. If you have a CDI bean, CDI supports various scopes, they call them. So session scope means it's stuffed in your HTTP session. Very simple. So it finds the instance, and then it goes through basically what I call services. So for EJB, there are more services than for CDI. EJB has transaction services. So what that means, if the container needs to start a transaction, it will start a transaction. If it wants to do security, it will check that you have the rights to invoke this method. It will then start going down the interceptor stack. Then it does this decorator stack, which is standard delegation. Then it hits the real instance, and then the call goes all the way back up to the top. So ultimately, at a very high level, CDI and EJB are very similar. So that's why a lot of people think, well, they're so similar, why can't I do all the same things with CDI beans that I can do with EJBs? And that's a fair question. And so in EE7, we added support for @transactional, which is now an interceptor, which is essentially identical to the EJB @transaction attribute annotation. So in JavaEE 7, now you can get container managed transactions outside of EJB in CDI beans. When we did this, we effectively did it by copying the annotation, making it look a little bit different, when in fact they're really mostly the same. So did we do a good thing there, or did we do a bad thing there? I guess that remains to be seen. There are a whole bunch of other annotations which we could do this with, which are quote-unquote EJB services that could be usable on CDI. So that kind of boils down to a philosophical question. Should we be copying and pasting these annotations as not EJB so that people don't hate them? Because that's really, if it has JavaX EJB in the package, there's a lot of people who are just simply not going to use them, even though they're really, really useful. So should we basically make a new version of this annotation that's going to, eclipse EJB and then make this the new way of doing things, and then you have two ways of doing the exact same thing and double to learn. But this way you'll not have to explain to your boss that you're not using EJB, you're just using this EJB annotation. Or do we just say, yeah, you can use all these EJB annotations on CDI beans? So I'm going to do a little informal poll. So who would want them to not have the EJB package? Okay, we have like 6 or so. Who thinks that it's a big mess and we shouldn't duplicate everything just for vanity's sake? There's maybe 12 or so hands, so more, right? You know, I'm not even sure where I sit on this. I see both audiences, so I'm on the fence. I've been obviously on EJB for a very long time, so I love it. But on the same time, I know there's a lot of people who will never be able to use it if it's got the EJB package, and that's just a shame. I don't know. If we keep going the way we are going, we will end up duplicating everything, and I think that might end up being a bigger mess and maybe a bigger detriment, but it's hard to tell. All right, so another thing that was a big initiative in JavaEE 6, which I hoped that we would continue in EE 7, was the addition of embedded containers. So, public static void main, I believe, should be yours to control, and there is no reason for you to put your app in a server if you just have one app. Why not put the server in your app instead? You know? I mean, why have to give up control of public static void main? If you're writing one app, you're going to bind it up together and you're going to distribute it. You know, take control back of your platform. That's a big philosophy that we've had. So in EJB 3.1, we added this thing called the embeddable EJB container, and it was a really big step forward, but it was also a step in the wrong direction. So I will, and as I basically was the one who kind of pushed that into the specification, it's a lot for me to say it was a step in the wrong direction. I'll tell you why it was a step in the forward. It was a step forward because it required all vendors across all the platforms to have and support an embedded container for what was perceived by the industry as the heaviest, bulkiest, most unwieldy, untestable part of JavaEE, which is the EJB part. That was considered to be the most ungodly beast ever in existence, when in fact it was never as complicated. Vendors were just doing it that way. So the specification never said, you know, your server must be heavy. It just said, here's how the component model should be work, and then the vendors did it in this incredibly heavy way. So I had been working on this container called OpenEJB, which was started as an embeddable EJB container, and so it got some traction with people who want to do testing of EJBs. We eventually got this concept of an embeddable EJB container into EE6 via EJB 3.1, and then that became part of the certification requirements, which means it became part of the test suite that all vendors have to pass in order to have a compliant EE6 server. So basically that meant WebLogic has an embeddable EJB container. WebSphere has an embeddable EJB container. So does JBoss, Glassfish, and of course Geronimo and TomEE, and all the platforms have an embeddable EJB container. Huge step forward, because now all the vendors are like, well, as long as we have to pay this cost, you know, let's do it right. So a lot of vendors are going beyond just EJB and doing more than just EJB in their embedded platform. Glassfish, JBoss, and TomEE all have full support for embeddability across their whole platform. So this came up now. Should we standardize this? We did EJB, awesome, but now let's do more. Here's where I say we took a step in the wrong direction. We compromised and did it just for EJB when we should have put our foot down and done it across the whole platform, because now we've made a bit of a mess. Now people want to copy what we did in EJB and other specifications, and now that sounds really awesome. But here's what these proposed APIs would look like. Well, this one exists, EJB container.create EJB container, and it gets you back an EJB container. Then you're going to look up EJBs from it, and you're going to execute them in your JUnit test and so on and so forth, or your Java SE application. So let's do that with all the specifications. All right, well, fantastic, but we don't write things in such silos. We write things integrated. In fact, we as a platform, JavaEE, are trying to integrate things together more. We're not trying to separate them more. We're trying to work closer together. So if you have this servlet, it's got a reference to an EJB. The EJB reference is a CDI bean. okay, I can kind of see what order I might want to start this. I would start the CDI container first, then I would start the EJB container, and then I would start the web container. Okay, great. Now what happens when I add a circular reference between the EJB and the CDI bean? What order do I start them in? And now at this point, users just throw their hands up, they smack their head against the keyboard and say, okay, this is a mess. And so while it would have been awesome to have embeddable web container and embeddable CDI container, I ultimately think it's the wrong way to go. Because while this may have worked in the first example, it certainly does not work now. You couldn't, with a circular reference and you're responsible for starting orders and all that stuff, that creates more problems for you than it does solutions. So the proposal that I brought forth was, let's just cut to the chase, get all the way to the end and make a generic embeddable container API that will work for anything in the platform. And then if you happen to use servlets and EJBs and so on, that will work. Ultimately, this got tabled, is the nice way to say it. It was agreed that this is going to be an important thing for the platform, but not a lot of vendors still have enough experience with this, and so Bill in particular wanted to wait till EE7 or EE8. The downside about this is that specifications tend to do what they want anyways, so the CDI version of this is probably going to go in the next version of CDI, regardless if there is a JavaEE general version. So the mess that we made in EJB 3.1 is going to be copied whether we like it or not. So I predict in the future you will have to deal with this problem before there is a JavaEE general API. If you think that's a bad idea, then again, your voices need to be on the expert groups, giving your feedback. Okay, so one thing that took a lot of cycles was logging. Now, it's here's what happened with this. So the need is clear, all right? There are a million logging frameworks, and one server uses one, another server uses another. Some of your libraries in one application use one, and some of your libraries in your application use another, and you really have no way to standardly configure this for any server, so ultimately this is a portability issue. Because your logging is not portable from one application server to the other, well then ultimately your application is not portable. So if you can't solve logging, then we really have a big gap in the portability concerns of JavaEE. This is ultimately true. The proposals were maybe to do a standard config file format. The proposals included maybe having a new logging API. The proposals included maybe a logging JSR. So these were some of the discussions that happened around the talk. But ultimately what happened here was more time was spent convincing people that this is a problem than presenting solutions. So it didn't actually come to any fruition. I think the lesson to learn here is, well, one, who of you watched the XKCD or like the XKCD cartoons? Yeah, all right. Well, there's this one that I really love that says, we're making a new standard to take all these to make all these other 12 standards irrelevant. And then, it shows, here it is, and then the last panel is reality. Now there are 13 independent standards, and that's sort of the deal with logging. The more logging APIs we add to create the one logging API to end them all, the more we worsen the problem by now there are more logging APIs to worry about, so there's no possible way that one person could standardize them all. So I don't know if this problem is solvable, but there's certainly a problem there. But ultimately there weren't really any concrete proposals on how to solve it, so it didn't go anywhere. I think the lesson is establish the problem, definitely, but be very, 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 very aware if you're not presenting a solution, you're wasting your time. It's okay to issue it, to say what the problem is, but if you are not following it up with some, here's how we make it better, then ultimately you'll find a lot of people who agree with you, and then it'll seem like you have agreement, so why isn't this problem solved? But you need to have some concrete ideas for some solutions. And that's really what the problem is. Also, there was a critical thing, don't ask for permission to solve a problem. That was sort of like, we should solve this. Like, there was a lot of, we should solve this, expecting someone to say yes. Okay, what if the head said yes, then what next? So don't ask for permission to solve problems. Just start thinking about solutions and skip all that stuff. Just jump over it. Okay, so some of the things that were talked about, and this isn't a good example of where we did have some user feedback. In EJB, there's an asynchronous capability, and ultimately this is kind of a complicated thing in terms that it raises other questions. So one proposal was, let's create a way to limit the amount of concurrency that you have, because with, say, an EJB singleton that has an asynchronous method, ultimately that means you can have basically an unlimited number of calls going through that asynchronous call. But the reality is, you sort of have a pool down there of threads, and you have a kind of a concrete limit. So, let's create an annotation that says, how many concurrent usages of this call should we allow? So if you had a really system-intensive call, and you didn't want more than, say, 4 of them happening at one time, you could just throttle them with this max concurrency API, a little annotation. This is inherently a doable idea, but what happened here is that when you're talking about simply limiting the number of threads, you can do that without having to mess with the concept of pools. Limiting the number of threads is as easy as counting the number of concurrent calls that are happening and saying, you got to wait until these finish. And you can do that with JavaX semaphore, for example, or Java util concurrent semaphore. So what happened was, this got tied in sort of incorrectly to the concept of asynchronous. It's ultimately not linked to asynchronous. You have multiple threads coming into any server, so all calls could essentially benefit from being limited. Doesn't matter if they're happening asynchronously or not, but this got pegged as a useful only for asynchronous, which led it off into a rat hole conversation or a different conversation, which is, one person said, well, let's create an annotation to allow you standardly control how many threads are in the thread pool of the asynchronous method invocation. So the justification for this proposal was, has all of the same needs as the, limiting the concurrency, but then it solves the problem of now you have a standard way to configure how many threads are in that pool for the asynchronous call. So the problem with this is that, when you consider only one example, I mean, it's really great. Okay, I have a thread pool of 20. All right, so now this can execute exactly 20 times. But now we start adding a ton more methods that all execute this way. How many thread pools are we going to have in our server? I mean, if we go this way, we're going to have, what, 100 thread pools for every usage of asynchronous throughout the entire application? Well, the second you have 100 thread pools, you've lost, because you really only want 100 or less threads on most servers. Limiting the number of threads is how you get performance, not guaranteeing that there are 100 thread pools of exactly 1 or more threads. That's not the way you get performance. So that creates more of a problem than it does a solution. It gets things going in the wrong direction. And so that was sort of an undoable idea. That was not a doable idea. That was an idea that couldn't really be executed. When you have 15 applications and you've tuned your applications to say that each one should have a fixed thread pool, you add another few applications, well, now you got to change the number of threads that are in each pool. And so it doesn't really work to do them on a per method basis. Then yet another user added to this same JIRA ticket, the same item. So now we're on the third idea. Well, let's set the priority of the threads. As long as we're talking about threads, this is sort of a common occurrence when developing specifications. There's a whole Me Too kind of a mentality. Oh, as long as we're talking about something that's sort of adjacent to what I'm talking about, I'm going to put my idea in there. It's good to get your idea out, but I encourage you to do it as a separate concept. If it is not entirely 100% linked to the API being mentioned, do it as a separate conversation. You'll get much farther with it. This was an idea, again, that could have gone in. So the idea here was that you should have an annotation or some ability via an annotation to say what the priority of the thread was. And that's very useful because if you have, say, a background process that's going to be churning through some records or doing some batch processing, you don't want that to take as much CPU as all the web requests coming in. You want that to be a lower priority. So allow for people to say that. That was a good idea. Ultimately, it was linked to asynchronous. It really didn't need to be linked to asynchronous. That's a good feature for any method call happening at any time. But it got linked to asynchronous because all this stuff was happening under the guise of asynchronous. So ultimately what killed this proposal was that it wasn't a good idea. It was that it was mixed in with a bunch of not so clear ideas, and so it suffered the same fate as the other ideas which weren't so good. And so that's a big lesson. If you have a good idea, it's a clean idea, try and make it separate and distinct and have it stand on its own, and don't tie it in with other people's ideas. It feels like you're going to get more support because you're linking it to some other idea, but that actually makes it harder to consider. So, focus your proposals, and you'll go much farther with them. And when you see someone going me too onto your proposal, make sure you kind of push that off to the side and say, yes, that's actually a different idea. Let's start a different JIRA ticket for that and talk about that over there, and we'll keep this proposal going on this idea. That's what Adam should have done when his idea got hijacked and then hijacked again. He should have just cleared that away and said, no, I'm talking about something very specific. And it probably would have gone in. Another bigger proposal that went in that got discussed, and this one didn't go in, and it wasn't because of kind of deficiencies in the community process, which is this concept of meta-annotations, and it's sort of like CDI stereotypes. And so the idea is for you to be able to abstract and reuse annotations. We have basically annotation bloat in JavaEE, and so it allows you to take, say, 10 annotations, boil them down to one annotation, use that one annotation everywhere. So instead of having hard-coded values spread out throughout your whole entire code base in annotations, you can boil them down to one and just use that everywhere. This has been added to a couple specifications, so the urgency of this is let's do this in a standard way so that other specifications don't continue to create their own concept of this. So Bean validation has annotation reuse in this fashion. So does CDI, and to a limited extent, JAX-RS does. So here's a quick way to try and boil this complicated topic down to a very simple perspective. So here are what you might see an EJB application if you're to use all the EJB annotations available on a method. This is essentially before, and here's what it might look like afterwards. Okay? Now, where did all these annotations go? Well, we can see we have an add annotation, and if we look at the add annotation, we see the other annotations that we would have used on the method. So now everywhere we use add, it implies these. Simple concept. And we had a delete method, and everywhere we use the delete annotation, it implies these annotations. So it allows us to consolidate all of our annotations down into one area. So ultimately, this was determined to be a good idea, and we tried to get this in as a proposal as an addition to CDI. It was determined that that wasn't really the right place to do it because that ultimately means that all these other specifications now are dependent upon CDI. So you couldn't use JAX-RS without CDI. You couldn't use JPA without CDI, and so on. So that got tabled as something we absolutely need to do in JavaEE 8, but ultimately too big for JavaEE 7. And I ultimately agreed with it because I think that, one, it shouldn't be tied to CDI, and maybe even JavaEE is not the right place to do this. Maybe a better place is in the VM as Java SE as a primary feature of the language. So who knows if this will go into E8 or if it will be down in SE at some point, but it's a very critical language functionality which I think we need to see at some point. This led to another kind of offshoot conversation, which is, well, since we wanted to put more things in CDI and use that everywhere, why isn't CDI enabled by default? If you haven't learned it already, which we had only maybe a handful of people who were aware of CDI, it's not on by default. You got to turn it on with this file called a beans XML file. If you don't have that XML file in your application, CDI doesn't work. So the idea was, all right, let's get this proposal in there. It kind of struggled for a while. Concerns were around performance. Concerns were around impacting on existing applications. We did do a poll at Java 1 in sort of a user-focused session. It was a BOF, had about this many people, maybe double. And yeah, majority of people said, get this in there right now. That's what got that into the specification. So ultimately, it was approved because of user feedback, even though vendors had concerns about the performance. Basically, they were told to figure it out. And so that's what happened. So it was a nice, good step forward based upon user feedback. And so that's a nice little yay community type of a change. This is the last one that I have to mention. So this is an interesting one. So this is the hardest to explain. So let's just say that this proposal is about unlocking the potential of a very poorly understood specification. And that's the connector MDB relationship. So it ultimately allows you to write servers, and then you can just let the container deal with all the dependency injection garbage and so on and so forth. So you might think of MDBs as JMS related, but they're not. They do have the ability to do anything, in fact. JMS is simply the only use case you've ever heard. And then that API, even though it does allow you to do these things, is deficient. It doesn't allow you to write today's modern API. So the proposal here was, let's redo this. So here is what a JMS message-driven bean would look like now. You've got your one on-message method. You're implementing an interface. And then everything is in annotations. And if you notice, those annotations on top are essentially name-value pairs. So you've got string on one side and string on the other. That's sort of a waste of an annotation, in my opinion. And then you have tons of boilerplate stuff in JMS. Who uses JAX-RS? Okay, quite a lot of hands. Who uses JAX-RS where you might have used servlets in the past? Yeah, see, if you don't really need to use the servlet anymore with JAX-RS. You can output HTML, and they're also ultimately a better API. Here's what the revamp would allow you to do. So instead of having all of this, notice we have a max sessions and destination type. Well, now the vendor could just make those annotations. And in fact, we don't have to put them on the class. We can put them on the method. And just like with JAX-RS, we could have the vendor go, well, I'm asking for an object message. Clearly, I want an object message. So it doesn't matter if you haven't given me an interface that allows me to implement a method that says on message with an object message. That's what I'm asking for. Figure it out. So this would allow us to write more advanced APIs, because ultimately right now, this connector MVD relationship does not allow that to happen. It sort of waters down all the thing. But that's not even as far as we could go. We could go like that. Why not, instead of having object message as the argument type, why not have, say that an annotation says the kind of message that I'm going to consume is object message, and then obviously the value of get object, you could just pass that in. So this is getting closer to like a JAX-RS type of API. And of course, instead of having one method, you could do two methods. And then, as I mentioned, it's not even JMS related at all. So here's a completely way off into left field proposal, which allow you to write, say, like a telnet server, and then have telnet commands sent into beans, and write your own annotations for all this stuff. So it ultimately would allow you to consume whatever you felt like consuming as requests coming into your server, and really allows you to extend your server in some pretty tremendous ways. This almost did not make it. So what got this through is a big push from the community. This is probably one of the bigger examples of a good community type of initiative. We got 25 votes for this proposal. We got 14 watchers. We had people actually helping to implement this in the RI. I actually did that work myself, even though I work on another server. And then we had people helping to do the tests for this. So really the community made this one get in, and ultimately did get in. So my time's up, but first I want to ask, I know we have another session, but questions on any of this stuff? Who would want to get involved in the JCP and get involved in JavaEE specs? Raise your hand. Really? No? You never had an idea if this should be part of the platform? Why is this done this way? I think that's what you should think about. When you're writing code and you find you're writing the same code over and over again, I think you should view those as valuable additions to the specifications. Anything you're doing on a repeated basis, those are good things for the specifications. Present those ideas in JavaEE 8, participate in the ideas that are there, and I think that will allow JavaEE to be more of an open source type of specification rather than a closed source specification. So I do encourage you all to get involved, and I hope you found some value from this presentation, and thank you very much for your time.